To determine the compressor receiver size, we have this system. This is the receiver or tank of the compressor, and then this is the compressor itself. So what happened? Compressor runs, and then it pressurized the gas inside, and then it raised the temperature to some point, and it has some maximum pressure and also some minimum pressure. So when the compressor is reach up to the maximum point, then the tank reach up to the maximum pressure, then the compressor is stop, and then it just stop, and then the minimum pressure. So after the pressurized the after the tank is pressurized, the compressor is stopped. Now let's imagine that this pneumatic cylinder is working by this compressed air. Now, when this cylinder is taking this compressed air, and then the pressure will start to decrease from this tank, and then it has some minimum value. Once it reaches that value, then the compressor is start again, and it start to fill up this tank with high pressure gas or air. So just simply, if we consider this tank as 0.1, and then 2 is the atmosphere basically. Most of the pneumatic system, after they use the compressed air is released to the atmosphere because it's not harmful, so it can be released. So that's one of the advantages of pneumatic system over hydraulic. So if we write the Boyle's law, which is P1 V1 is equal to P2 V2, we can change that. 1 is basically the receiver, so we can say PR, and then VR is equal to, and then 2 is basically the atmosphere. So we can say V2 atmosphere. And we can also, instead of volume, typically for a compressor, we are interested in flow rate. So we can just simply do VR divided by T, and then P ATM, V ATM, atmospheric divided by T. Now, so we can do, we can just solve for VR to find out what is the size of the receiver. So you can say P atmosphere times T, that comes from the left side, and then V ATM. Now it's not V anymore because we divide by T, so it's going to be basically Q atmosphere. So how much, if we release that amount atmosphere, what is the volume flow rate for that? Now PR compressor. So we can do a little bit more modifications. PR, the receiver pressure, that is the operating pressure, is between max and the minimum, and then P atmosphere pressure, atmospheric pressure times T, and this Q ATM, we can write that. Imagine that the system is using Q at a rate of QR. So this system is using at a rate of QR. So this system drawing gas at a rate of QR from here, and then if the compressor is still running and then pressurizing the system and providing QC, so the rate of consumption would be something like this. So that's the volume. So this equation we could use to determine the size of the compressor. The size of the compressor, or should be actually tank or receiver. We got CEIVR. So compressor, tank, or receiver.